Welcome all. Hope you are good. Let's start with the new topic in Maths Concepts and Skills, Chapter 4, Data Handling from Learn Forward, Feather Cap. Now, data handling, as you must have learned in earlier classes also, it can be represented in the form of pictograph and bar graph. Today we will learn about these two and one more method of representing the data. Here is an example you are looking at. It is a double bar graph. It is a double bar graph given along where the marks of Shivai and Ankit are shown in various subjects: English, Science, Maths, Hindi and Social Science. How many more marks did Shivai got in Maths than Ankit? We will look at this particular side. So, it is representing Shivai. The marks of Shivai are represented by pink color and the green color is representing the marks of Ankit. You can see the marks of Shivai are 50 in Maths and the marks of Ankit are around 45 in Maths. So, the difference of marks is of 5. 50 minus 45 is 5. Again, which subject Shivai and Ankit get equal marks? Equal marks you can see in this particular area. The marks of social science are equal. Social science. Same way, next question you can see. And another one is difference between the marks of Ankit and Shivai in English. These are the marks. Shivai got 40 marks in English and Ankit has got 60 marks in English. So, the difference is 20 marks. Now, why we do data handling? The data handling is done so that at looking at the graph or the pie chart, or the pie chart is one more important way of representing the data. We will be doing it, and pictograph you must have done in class 5th also. Now, one more is bar graph. So, by looking at these ways of representing the data, we can get the knowledge from the given large data. Data handling is a process in which the data collected, suppose you are collecting the attendance of a class for a particular month, stored, classified and analyzed. Its presentation is done by various methods. That means what we are doing in data handling, it is stored, classified and analyzed. Suppose we store the present number of students present in a particular class in particular month. So, how can we do the classification? We can do the classification in 3 ways: the number of students absent in a particular month, the number of students they are present in a particular month, and the number of students on leave in a particular month. And then we can analyze how many students are mostly absent in a given month. So, this is the way we can do by data handling. It is a pictograph now. Example 1 is shown here. It is a pictograph which uses pictures or symbols. It uses pictures or symbols to represent the value of the data. Here, 1 apple is representing 3 apples, and the pictograph shows the number of apples eaten by students of class 6th, 7th and 8th. So, in class 6, 1, 2, 3, 4, 5. 5 into 3, 15 apples are in class 7, 1, 2, 3, 4 apples are eaten. So, 4 into 3, total 12 apples are eaten. Again, how students of which class has maximum number of ate the maximum number of apples. Here you can see 8th class has eaten the maximum number. We can see from this side also by counting the number of apples and by calculating the total number of apples eaten by class 8th. 1, 2, 3, 4, 5, 6. 6 3s are 18 apples are eaten by class 8th. Now, dash more apples are eaten by students of class 8th than the students of class 7th. Here we have shown that it is 18. Now, by class 7th, the number of apples eaten are 12. So, the difference is 6. So, difference of 6 apples in the number of apples eaten by class 7th and 8th. Now, next topic is bar graph. It is one of the method of representing. I told you first method, then second one is by bar graph. The bar graph uses bars that are equidistant to each other. Bars that are equidistant to each other. Suppose I am representing my data in this way, 0, and this is my y-axis, this is my x-axis. So, if I am taking the difference of 1 centimeter on x-axis, suppose, and on y-axis also, if I am taking the difference of 1 centimeter for representing a particular data, suppose these are the product marks, product test and marks scored in a particular test by the students. So, this should be equidistant. The bar graph should be, if I am representing this way, the difference between the difference between these two bars should be equal. This is 1 centimeter here, and if I am representing this by another, so difference is here also 1 centimeter. So, these are equidistant from each other, and the equal width is also equal of different height. Height is different, as you can see that height is different, but width is also same, 1 centimeter. This is what we call a bar graph. The height is different, but the difference between the bars is equal, and the width of each bar is also equal. Now, let us draw a bar graph and answer the following questions accordingly. Here is a periodic test 1, 2, 3 and 4, and the marks scored are 17, 20, 17 and 19. This is the bar graph we will get after representing this data. PT1 marks 17, 16, then this is 19, PT1 mark 17, then 20, 17, 19, PT1 17, then this is 17, suppose this is 19 now. The student scores maximum marks 20 in PT2. The question was, in which test is the student score maximum marks? You can see here, from here also, that 20 marks are obtained in PT2. In which test the student score minimum marks? It is PT1 and PT3. PT1 and PT3. 17 marks are scored by the student, and total marks obtained in PT1, PT2 and PT4. Total marks in PT1, PT2 and PT4. PT1 17, 17. Marks in PT1 17. Marks in PT2 20. PT2 are 20, and next PT4 is, you can see from here also, from the bar graph also, and it is 19 in next PT. So, this all will give you after addition as 56, and you can add from the here also. This is 17 in PT1, PT2 is 20, PT3 4 is 19. 19, 20 and 90. Now what is double bar graph? Double bar graph when we draw two sets of data simultaneously. Two sets of data. Suppose we are representing the temperature, minimum and maximum temperature of two of the cities, Chennai, Delhi, Mumbai and Kolkata. This is a maximum temperature for this particular city and minimum temperature for Chennai is 28. We are representing the data on a same graph and the color of this maximum temperature we had taken by pink and the blue shows the color of the minimum temperature for that particular city. Chennai 39 is the maximum temperature and 28. This is 28 representing 28. This is 39. Again for this city this is 44. This is 35. For this city 36 and 27. This is a minimum temperature. Last one Kolkata is 38 maximum temperature and 30 is the minimum temperature. In which city the highest temperature among all? Highest temperature here you can see it is 39, 44, 36, 38. So maximum temperature is of this city, that is Delhi. This is Delhi. Now which city has lowest temperature among all? We can here go for the maximum temperature of all the cities, comparing the maximum temperature of all the cities. Lowest temperature of all is, I think this is 36. For which city? Mumbai. You can see from here also 39, 44, 36, 38. This is the least or the lowest temperature. In which city the difference between the maximum and minimum temperature is the lowest? The difference between these two is the lowest. Here it is 39, 28, 48, 44, 35, 36, 27, 30 and 38. Here also we can see, but for looking at the graph it makes us easy to calculate. Difference between maximum and minimum temperature of all the cities: Chennai 11, Delhi 9, maximum and minimum temperature difference. This is 11 here and this is 9 here, again 36, 27, 9 here and this is 8. So you can see the difference between the minimum and maximum temperature is lowest in Kolkata. In Kolkata. Now this is the very important topic we will be introducing you in class 8. Circle graph or pie chart. This is the third method. We have gone for the pictograph, then bar graph. Two types of bar graphs are there. एक single था and second one is double bar graph. Single and double. And third important, three ways of representing the data. First one is this one, second one is this one, and third and the most important we will be introducing in class 8th is circle graph. We will call it as circle graph or pie chart. Okay. Now what is this? It is representation of the data in the form of a circle. When we represent the data in the form of a circle, we call it as pie chart or a circle graph. Pie chart or a circle graph. Pie chart allows or shows the relationships between a whole and its parts. The whole circle is divided into sectors. each sector visually represents an item as a percentage or a fraction of the total data. Since the circle is angle of 360, angle at the center is 360, so we complete the circle represents, and the complete circle does represent 100%. We are converting the circle into sectors, and sectors representing the percentages, and complete circle does represent 360 degree, hence the percentage is 100% for that particular circle. And these are the steps for drawing the pie chart. First step is obtain the data and find the sum of various components. Suppose this is an example, I am comparing the steps with this. The number on his birthday, Amit bought the following items. These are the items and these are the number of items: chocolates, toffees, balloons, caps and patties. So first of all, obtain the data and find the sum of various components. We will find the sum of the various components: 50, 30, 20 and this is 30. 50, 30, 20 and 30. Calculate the central angle for each by using this formula. Central angle is value of the component. Suppose we are doing 50 upon the total into 360, because we are representing the data in the form of sectors in a circle. So the complete angle is, as you know, is 360. So we will multiply by 360 after dividing. Third step is draw a circle of any radius. We will draw a circle of any radius. Draw the horizontal line that represents the radius of the circle, and starting with the horizontal radius and moving in a clockwise direction, we will draw sectors using the central angles, and we have calculated in step 2, and shade the sectors using different colors or design or name them. Colors, designs and name them. Name them means we will represent, after representing in the form of sectors, we will name it as this particular area or this particular sector portion is this particular angle representing the number of items: toffees, balloons, caps or patties. So first step, first question is given to you: find the sum of all the items. Find the sum of all the items. Here 50, 20, 50, 30, 20, 50. 20, 50, 30, 20, 30. It will add up to 150, first step. Then in step 2, we have to calculate the central angle for each. This is the angle for toffees, 20 upon 150 into 360. Second one for toffees, 50 upon, this is for chocolates, central angle for chocolates, because the number of chocolates are that the Amit has brought is 20. 20 upon 150 into 360. So by using this method, dividing by total number of items and multiplying by 360, we will get the central angle for each, and this way we will represent the angle. After this, we will draw a circle of any radius whose center is O, or we will draw a radius of any radius or that particular circle, and then on moving clockwise, for suppose we have to represent 48 degree, we will draw 48 degree here and name it as toffees or chocolates, whatever it is. It is for chocolates. It is for chocolates, so it is representing this way, then toffees area, then balloons, then caps and patties. Now this is another example. As we have done the construction of pie chart for this example, example number 4, now we will read the graph and answer these questions. Here the given pie chart depicts the expenditure of a family on a various needs and the total expenditure is 7200. So that means 7200 rupees 7200 is represented by this circle, and that is 360 degree for complete 7200. So 1 degree will be representing rupees 20. 1 degree will be representing rupees 20 in that case. Now, in which item the maximum amount is spent by the family? For the maximum amount to be spent, we have to look for this, because the maximum angle is this, and then we will multiply it by 20 to find out the expenditure on food. But they are asking only about the article, so it is food. On which item minimum amount is spent by the family? For minimum, we will go for minimum angle, that is a rent part. The expenditure on rent is minimum. How much money is spent? For that we have to solve education 50 degree. 50 degree, here we have seen 1 degree is representing 20 rupees. So 50 degree will be representing 50 into 20, that is rupees 1000 on education. How much rent is paid? That is 30 degree into 20, that is 30 into 20, that is 600. In this way, by how much amount the spent on money, how much amount spent on education, clothing and rent exceeds the amount spent on food. So we will solve on education, clothing and rent and subtract it by, because maximum amount is spent on food, we will compare it. Oh, this is food, we have done with this part also. Now for clothing and rent, this is the angle. Clothing, rent and education, total angle is 140 degree and central angle for food is 130 degree. So difference is 10 degree. Hence the amount spent on education, clothing and rent exceeds, because we are showing that 1 degree representing rupees 20. So difference, if difference is 10 degree, so 10 into 2, 20 is 200 amount is spent more on these three, that is education, clothing and renting, compared to the amount spent on expenditure on food. So these are the now some common errors students usually do. When the values are in percentage, they should be total up to 100. We have already told you the angle is 360 degree, angle at the center of the circle 360. So angle should be 360 degree and the percentage should be equal to 100%. Total percentage should be equal to 100%. You can see here 90, 130, 30, 60, 150, 50, 60, 110, 110 plus 30, 140, 140 plus 90, 230, 230 plus 130 is 360 here. Degree is 360 and the percentage, if you can calculate, it should be 100%. So in this case the percentage is not equal to 100%. It is not a correct way of representing the data, but here the percentage is adding up to 100. So it is a correct way of representing a pie chart, circle graph or a pie chart. Now this is the exercise for you. Two different schools give different timetables to the subject, shows the time of each using a double bar graph. We have to represent this with a double bar graph and then we have to answer these questions according to the graph you draw. Next topic is chance and probability. end this topic. When we perform experiments like throwing of dice, tossing of coins, chances of predicting rain tomorrow, we have to find out the outcomes of the experiment. Probability plays an important role. In that case, when we throw a dice, toss a coin, and chances of predicting a rain tomorrow, we have to find the outcomes of that particular experiment. Experiment here is throwing a coin or throwing a dice, tossing a coin. That is an experiment here. Probability is an important role in that case. What is probability now? The chance of happening of certain things. Chance of happening of certain things in unknown or uncertain circumstances. Unknown or uncertain circumstances is called probability. We calculate this with the help of we can solve probability numerically. Getting a result. What is getting a result in probability? This is the topic. The experiment in which the result cannot be predicted, in spite of knowing all the possible outcomes, is called random experiment. Suppose I am tossing a coin, so I don't know whether the head comes or the tail comes. That is a random experiment for me. For example, when we discuss about chances of a rain tomorrow, it may be rain or it may not rain. So it is not under our control. This is called a random experiment. That is, rain or no rains are two possible outcomes. Two possible outcomes in this. I have explained you again about tossing a coin. When we toss a coin, we don't know whether a head comes or a tail comes. So it is also a random experiment. Write all possible outcomes for this random experiment. When we spin a wheel showing above, drawing a ball from a bag of 10 balls, among 10 balls, 2 are red, 2 are green, 2 are blue, 4 are yellow, getting a number when a dice is rolled. So possible outcomes are red, blue, green, yellow, orange. When we spin a coin, the outcomes can be the spin stops at position yellow, or it can be at orange, green, red and blue. So outcomes are these 5 colors. For this particular case, the outcomes are R1. If I represent the number of red balls as R1 and R2, then green balls G1 and G2, blue balls as B1 and B2, yellow balls as Y1, Y2, Y3 and Y4. So these are the possible outcomes for this particular bag of balls. And the possible outcomes when a dice is thrown is 1, 2, 3, 4, 5, 6. Any number can come when we throw a die. Outcomes as events. An event is a collection of outcomes. So it is a collection 1, 2, 3, 4, 5. It is a collection of outcomes. For example, when you toss a coin, possibilities of getting head or tail. So each result is called an outcome. Similarly, when we draw a dice, possible outcomes are 1, 2, 3, 4, 5, 6. Again, for this bag, the outcomes are R1, R2, G1, G2, same way. And for this, the possible outcomes are red, blue, green, yellow, orange. Equally likely outcomes. What is equally likely outcomes? When the chances of getting the outcome is equal, all the outcomes of an event has same chance of happening. It can be possible that when we toss a coin, head comes or a tail comes. There are 2 possible outcomes only. So this is a chance of equally likely outcomes. When we toss a coin, it has 2 outcomes. It is either head or a tail. So it is a equally likely chance of getting a head or a tail, not equally likely event. So because as you have seen, 1, 2, 3, 4, 5, 6 also we can take, because we don't know which number comes on throwing a dice. If a bag has 4 balls, 3 red and 1 green, so possibility of getting red ball is more as compared to the possibility of getting a green ball, because number of balls for red is 3 and the number of green balls is only 1. So R1, R2, R3, G1, these are the 4 outcomes, and so they are not equal chances of occurring. So it is not equivalently, again a dice, as I have already told you, on the top of the die, on the faces of the die, the numbers are 1, 2, 3, 4, 5, 6. So this is also a not equally likely outcome case. Probability of getting the outcomes of 5 is 1 upon 6. 1 upon 6. Why it is 1 upon 6? Because total numbers are 1, 2, 3, 4, 5, 6, and getting 5 is, the probability of getting 5 is only 1. So what we do? Probability of getting 5 equal to number of outcomes for 5 is 1, and the total number of outcomes are 6. So it is 1 upon 6. Sample space. Now what is sample space? Sample space is this: when we throw a coin for first time, either a head or a tail appears. For the second time, it can be tail or a head here. Or for the second time, what we can say? Tail or a head here. By this way, we can find the chances are head head, head tail, head head, tail tail, and tail head. Tail head is this one, fourth one. Now head head is second one. Head head, this one, head head. Head tail is this one. Tail head is this one, and tail tail is this one. So this is representing the sample space for if we draw the die twice. If a coin is tossed one time, then the possible outcomes are head and tail. I have told you. For 2 times, then these are the possible outcomes, or this is the samples. These are the possible, these 4 cases are the outcome, and this, if we represent it together, it is a sample space. Probability of an event. How can we find the probability of event? Is the number of favorable outcomes or event and the total number of possible outcomes or a sample space. Total number of possible outcomes or a sample space. This is a total number. These are the total number of outcomes, and if we put together, it is making a sample space. So NE upon NS, NE upon N is P is numerical value of occurrence of an event. For example, if we throw a coin 2 times, then what is the probability of getting at least 2 heads? At least 2 heads is this particular case. So 1, 2, 3, 4 are the 4 outcomes, and out of this only one particular case is there when we get 2 heads. So probability of an event or a probability of getting at least 2 heads is 1 upon 4, because this is one time, and this total number of cases are outcomes are 4. So the probability is 1 upon 4. This is a very important point I want to tell you. Probability of an event lies between 0 and 1, and it is not less than 0 and not more than 1. probability is between 0 and 1. Either the event occurs or not, it depends on it. Suppose the event is a sure event, then the probability is 1, and probability of impossible event that never happens is 0. Suppose I say sun rises in north, so it is not possible, so it is a impossible event, so the probability of that particular event is 0. Next is example 7. Of getting a probability, we have to find the probability of getting a black card from a deck of 52 cards. For a black card from the deck of 52 cards, deck of cards contains 52 cards, and we have to find the probability of getting black cards among 52 cards. The total number of cards in a deck of 52 cards, the number of black cards are 26 and the number of red cards is also 26. So, for probability of getting a black card, possible favorable outcome is 26 and the total number of cards are 52. So, the probability of the event is, probability of the event we represent in this way, probability of an event is 26 upon 52, that is 1 upon 2, that is 1 upon 2. The total number of cards are 52, number of black cards are red, and number of red cards are also 26, 26, 26, total number of cards are 52. So, probability of getting a black card is 26 upon 52, that is 1 upon 2. In a simultaneous next example, throw of a pair of dice, find the probability of getting total more than 7, total more than 7. When we draw a sample space for this, because that dice is thrown simultaneously, so what we have to do, the first is 1 1, then second is 1 2, this way, so it ends up to 1 6. Because why I am making it this way, because on first thrown the die has number 1 and on second throw it also the number 1 also comes on, number 1 comes, and this way 2 1 2 2 till 2 6, 3 1 till 3 6. This is a sample space I am telling you. 4 1 4 6 6 5 1, sorry, 5 6 6 1 6 6. So, in this way the total number of outcomes will be 36. Number of outcomes will be 36, but what we have to find the probability that the sum is more than 7. First case, if we go 1 7 till 1 6, it is not more than 7, we will delete it. 1 2 1 2 3 4 5 6, this is deleted, this case is because more than 7 is required as per our question. 2 1 is also, 2 plus 1 is 3, 2 plus 2 is 4, 2 plus 3 5, 2 plus 6, 2 plus 4 6, 2 plus 5 7, but we know we have to find more than 7. So, first is 2 6, 2 6, 2 6, after 3 1 will be taken or not? No, okay, good. 3 1, 3 plus 1 is 4, it is not taken in that case. First is 2 6, we will take it, consider it as a favorable chance. Next 3 1, 3 3 not taken, 3 4 not taken, 3 5 we will take 3 5, 3 6 also we can take. It is sum is 3 plus 6 is 9, 4 1 we won't take, 4 2 we won't take, 4 3 we won't take, 4 4 next is 4 4, 4 5, 4 6. Same way we go for all the events, and this is a total number of cases which we have to take: 2 6, 3 5, 3 6, 4 4, 4 5, 4 6, 5 3, 5 4, 5 5, 5 6, 6 2, 6 3, 6 4, 6 4, 6 5, 6 6. So adding all the events possible outcomes, and the possible outcomes I have told you it is 36, and favorable are 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. So what is the probability? It is 15 upon 36. 15, because favorable outcomes are 15, we have to take the sum is more than 7, and the total number are 36. So it is 5 upon 12. Common errors use again. Probability when a dice is rolled simultaneously, the getting at most sum is at most 3. At most 3, the favorable outcomes are 1 2 2 1, that is number at most, sum at most 3, so it is 2. Hence the probability, the favorable outcomes are 1 2 3 3, but we are not considering it, or we are not considering 1 1. At most 3 means maximum is 3, but we can take it less than 3 also. So it is 3 upon 36. Now example number 9. A bag has 10 identical balls of different colors: red, green and blue. Number of balls of red color are 3, green are 3 and 4 are blue. So total number of balls are 10, and we have to take out a ball randomly without looking at the color of the ball from the bag. What is the probability of getting blue color ball? Because number of balls of blue color are 4 and total number of balls are 10, so the probability will be 2 upon 5. 2 upon 5. Now next example, a bag has 6 dark chocolates and 5 white chocolates. Total number of chocolates are 11 in that case. Total number is 11. They are of same size and shape but differ only in color. Color difference is there because it is dark color and this is of dark color chocolate, and it is a white chocolate. Chocolate, without looking at the we have to take up chocolate from the bag without looking at into the bag. What is the probability of getting dark chocolate? Number of dark chocolates are 6 and the total number of chocolates are 11. So the probability of the event will be 6 upon 11. Now uses of probability in real life. You must be asking, ma'am, why we are doing the probability and what is the use of probability in real life? Meteorological departments predicts the outcomes of different climatic conditions using the phenomena of probability. India winning the hockey match, cricket match, we can find out the probability. Or toss a coin in a particular match, growth of particular crop in this year, and so on. So these are some of the examples of our daily life where the probability can be used. Now what we have done in this chapter, we have represented the data in the form of circle. That is a very important part. That is a pie chart we have introduced you in the class 8th class maths. Central angle, we can find out the total number of components upon the value of that particular the total angle, central angle by the value of the component upon the total number of components. The chance of happening certain things is called probability. The experiment in which the result cannot be predicted is called random experiment, because we don't know whether the head comes or the tail comes. That is a random experiment. Event is the collection of all the outcomes. I have told you 1, 2, 3, 4, 5, 6. These are the outcomes, and the collection is event. Collection is sample space or event. The collection of all the possible outcomes is called sample space. Outcomes, collection of outcomes. Event is a collection of outcomes. Collection of all possible outcomes is sample space also. Probability is the number of favorable outcomes and the number of possible outcomes. Now, these are the some competency based questionnaire. A bag has 4 red and 2 yellow balls. Probability of getting red ball. Red are 4, yellow are 2, total are 6. 4 upon 6, that is 2 upon 3 is the probability of the event. Adjoining pie chart shows the spending of family on various heads, then the amount spent on food they are asking and the rent together. Since the total amount is 25,000, we will divide 25,000 by 360 and that we will get the 1 degree value. 1 degree spending of a family, 25,000 is the total amount and the total degree is 360. So, 25,000 upon 360 gives you the amount. How much amount is represented by 1 degree, and what we have to find amount spent on food and rent. Food is 14 and this is 45%. So, also if since the angles it is not representing by the angles, we can directly find out 14% of 25,000 for food, and for rent it will be 45% of 25,000, and we will add these two and get the answer. Now, rupees 700 out of the total of the amount of 2100 is spent on food. 700, the central angle is 120 degrees. Central angle will be 120 degrees. This is the answer, because this is the item and this is the total amount spent. So, and we have to multiply it by 360 degree since the answer is in degrees. The set of all possible outcomes of an experiment is called sample space. Collection of all possible outcomes is called sample space. An event is a collection of outcomes. Now, next question, the probability of an outcome lies between 0 and 1. The probability lies between 0 and 1. So, answer is D, 0 and 1. The probability of choosing a month having 30 days, choosing a month if having 30 days, number of months 12, total number of months are 12, and going on in January 31, 32, in January 31, Feb. If it is a leap year, it will be a 29 years, or not a leap year, then it is 24. So, that is also omitted. 31 in March. Now, April will be considered, May will not be considered again. April, May, June will be considered, July will not be considered. January, February, March, April, May, June, July will not be considered, August will not be considered. You must be knowing this method. Then September, in this way you can find out the number of months where the number of days are 30 days, and then we will keep that value here and divide it by 12, because the total number of months are 12. Coin is tossed 2 times, the probability of getting at least one head, these are the possible outcomes I told you for tossing a coin. So, it is asking at least one head. So, this one, and this one, all 3 will be included, and 3 upon 4 will be the answer. 3 upon 4 will be the answer. If an event is impossible, the probability is 0. The probability is 0. Next, in pie charts, fill in the blanks. In pie charts, observations are represented in the form of sectors of the circle. Dash is the chance of an outcome. Find out what is the chance of an outcome. The results of an experiment is called, the results of are called, this you have to do in your homework. This also, I think you are confident enough to do these kind of a question. This is a lab manual. Now, hope you enjoyed the session of data handling and new topic that I had introduced. I don't think you have any doubts regarding it. If you have any doubts, we will solve it in another session. Happy learning from Learn Forward. Thank you so much.